Hi guys, this is Miss Brazier. Sorry I can't be here today, but I'm hoping that these video notes will help you understand equilibrium systems a little bit better, help you be able to complete your book assignment and have it ready to go on Wednesday, and then also help with the review assignment as well. So please follow along, use the note-taking guide. I'm going to allow you guys to use the note-taking guide on your test on Friday. So it's definitely in your benefit to fill that in as we go through this. So what I want you to know is that some reactions are reversible. Usually we learn about reactions as reactants and products, and they only go one way, but the vast majority of reactions in real life do not meet that criteria. Reversible. Sorry if that's not spelled correctly. Rather than showing an arrow like that, which is a reaction proceeding just one way, we show reversible reactions with a double arrow. So one arrow showing going that way and then one arrow going the other way. So an example of this in real life is when we have carbonation in soda. And this is an example of like how carbonation is put into soda and other drinks with carbonation in it. So there's carbon dioxide that's dissolved in the liquid portion, and then there's also carbon dioxide that is a gas that escapes when the bottle is open. So what happens is the carbon dioxide in gas is being converted to dissolved carbon dioxide, and then it can go back the other way as well. The reaction goes from a gas to dissolved when you increase pressure, and the way that we do that is by adding carbonation artificially. So we're putting CO2 into this. We're turning carbon dioxide in its gas form into carbon dioxide in its dissolved form in the liquid. This reaction is reversed when we open the lid, and what happens is by doing that we're decreasing the pressure, and then the dissolved carbon dioxide is returning back into the gas version of it. And this reaction can go back and forth as well. We say that a system is at equilibrium when the products and the reactants are no longer changing. So the rate at which they are going back and forth remains constant. And I'm hoping with the lab where you put water back and forth and stuff that you learned that really what equilibrium was and got a good example of that. So going back to our soda example, a bottle of carbonated water with the top on is at equilibrium because so the amount of carbon dioxide molecules that are turning into a gas and turning into dissolved remain constant. When you remove the top, it's no longer at equilibrium, and the carbon dioxide that's dissolved, there's a higher rate of it turning into carbon dioxide that's in its gas form. Okay, so this is the big stuff that you want to write down in your note-taking guide, so please make sure you have that with you. So what I want you to know is that systems in equilibrium respond to minimize change. So basically they want to stay as same as they possibly can, and that's called Le Chatelier's principle. There's three different factors that can make a reaction favor the right side or the left side. And by doing that, you can basically decide whether you want to make more of certain things on either side of the equation, which can be really useful. So the first factor is temperature. Increasing temperature favors the reaction that absorbs energy. What that means is the side of the reaction that is either endothermic, meaning that heat is being added. Another way to know this is endothermic reactions, decomposition reactions always meet that same criteria. The next component is pressure. Increasing the pressure favors the reaction that produces less gas. So remember back to our balancing equations, you look to the side with less atoms of gas, and it's going to favor that side of the reaction. So more of that side is going to be produced. The final factor that affects which way a reaction goes is concentration. So increasing the concentration of one substance favors the reaction that produces less of that substance. That goes back to our rule that systems in equilibrium, they want to stay as the same as possible. So they're going to try to mitigate any changes that are made. So let's take a look at your assignment. There was a couple questions that I think were a little bit confusing, and I'd like to go over them together. So number 7 in your book assignment, it was the 5.4 reading guide, asked you what the effect was of an increase in pressure on this equation. So we have 2 atoms of this gas plus 7 atoms of oxygen gas. The reaction is reversible. It's said to be in equilibrium, and we know that because of this notation. 6 atoms of liquid water and then 4 atoms of carbon dioxide gas. So we look and we say, which side of the reaction has more atoms of gas? So it's definitely going to be this side. So let's look back at our rules, and it says increasing pressure favors the reaction that produces less gas. So increasing pressure is going to make the reaction go more to the right because it has less gas. Let's take a look at number 8. So this one is asking how you can change temperature and pressure to make more calcium carbonate, meaning make the reaction go to the left. So we want to make the reaction go more to the left. So for temperature, let's look back at our rules again and see what the rule is. So it says increasing temperature favors the endothermic reaction. So that's the one where you're absorbing energy. So if I look over here, heat is being added, meaning that this side of the reaction is endothermic. So if I increase the temperature, I am going to make the reaction go to the left, and I'm going to make more of this calcium carbonate product. So I want to increase my temperature. Let's take a look at pressure. So on this side, there's no gases. On this side, I have carbon dioxide gas. So we know this side of the equation has more gas than this side does. So looking back at our rules, increasing pressure favors the reaction that produces less gas. So this side has less gas in it, so I'm also going to increase my pressure, which is going to make this reaction go more to the left, which is going to make more of the calcium carbonate product because there's less atoms of gas. There's actually no atoms of gas on this side than there is on this side. Okay, so please put your note-taking guide somewhere really safe. It definitely wouldn't help or wouldn't hurt to do the review, having that out in front of you so you can practice using those notes. This really takes some practice to get used to this type of problem. And I'm hoping that this clarifies and helps you out with this as well. On Wednesday, we can also go over these in person if that would help. All right, have a good day, and I hope you guys are super productive, and thanks for being your awesome selves.